Okay, good morning, everyone. Welcome to Thursday morning at the Dev Summit. It's surprising to see so many people up so early on a Thursday morning on a conference and stuff like that. Good job. Welcome to a presentation where we're going to talk about effective geodatabase programming. Up here on the stage, we have Colin Zwicker. What do you do, Colin?
Turn on my mic. I'm the lead test product engineer for the GeoDatabase team.
How long have you been working on the GeoDatabase?
A long time, 14 years.
Okay, so you know a thing or two.
A couple things.
Okay, my name's Eric Hall. I'm the lead dev on the GeoDatabase. Working with Colin for 14 years. Actually, we started here at Esri in '97 when we first started ArcGIS way before we released 8.0. So we've been dealing with the GeoDatabase now for 21 years. It's been around for a little while. Anyway, continually under advancement and development and all that. You'd be surprised. It's just constantly working. Now, I have a question for you guys. How many of you are actually writing ArcGIS-based code using ArcMap or Engine? Could you raise your hand? Okay, it looks like a majority. How many of you are actually using ArcGIS Pro and writing managed SDK-based code? Okay, interesting. It's less people, but still a good number of people. Maybe a third of the crowd seems to be doing that. Now, what we're going to be talking about in here, a lot of the examples that we're going to go through are a little bit more ArcObject-centric in terms of looking at the code that's being displayed and all that. However, all these principles, most of these principles all apply to using the managed SDK as well. Towards the latter half of the presentation, the second half, Colin's going to take us through quite a bit of the managed SDK and explain how the managed SDK of the GeoDatabase actually works and give some examples and give you some good pointers and all that. So anyway, we have 80 slides to get through and like 58 minutes left, so let's get going. Keep in mind, a lot of this material is meant to be for reference, okay? We may not talk to every single bullet point, but you'll be able to grab these slides after the fact and use them at your desk when you're doing your work, and they're a good source of reference material. Actually, it's kind of interesting because for GeoDatabase developers, we oftentimes, Colin and I, hand them out this presentation for clarification on proper ways to implement certain things and to uphold the various contracts and all that. So this is some good material, and I hope it serves as a decent reference to complement what we already have online. So anyway, what's this all about? The important information that allows you to be an effective GeoDatabase developer. Okay, and we're going to try and provide you with a little commentary and additional insight as to why certain things were being done or what things are particularly important to keep in mind, things that may not come out as strongly as they should in the online doc or whatnot. We'll go and emphasize certain key topics. We're going to focus on a lot of best practice type issues. We want to go through and answer some of the common questions that Colin and the team gets back in Redlands, looking at the forums and going through tech support and all the rest. And Colin will be talking to us a lot about some of the new development patterns using the managed SDK in ArcGIS Pro. So we're going to assume here that everyone understands the GeoDatabase. We're not going to take you through the GeoDatabase information model or the transaction model and explain how that all works. But we're assuming here that you do have some experience programming against the GeoDatabase, and you do have a good working knowledge. Code examples will be in a variety of languages. Doesn't really matter the language. We can all translate from one language to another. There's a lot of stuff here, not much time. We'll try and get through it all, and it is intended to be a reference. Here are the main topics that we want to talk about. We're going to talk about the unique instancing of objects inside the GeoDatabase. We'll spend a good amount of time talking about cursors. Cursors are actually a very subtle topic that, even we internally sometimes forget some of the key details, and we're going to take you through those. We'll talk about caching of data, not just the spatial feature data, but also the schema data, all your metadata and whatnot that's associated with your information model. We'll talk about Schema Locks, and then Colin will take us into a interesting journey through the Pro Managed SDK, take us into core.data. Given that we just released 2.1 about a month and a half ago or so, CoreData is actually getting fairly mature, and there have been some big additions to it being made during this last development cycle when we did release the utility network information model to address networking concerns for utility customers. And then this is actually a good thing. Colin's going to take us through and discuss the top developer mistakes. What are the mistakes that people seem to make over and over and over? People have been making these mistakes for 20 years. We make these mistakes. You make these mistakes. It's good to get the refresher, and Colin will take us through all that, and hopefully that'll be very useful material to you when you get back to your offices and start doing more interesting things than sitting in here on a Thursday morning. So, unique instancing. Inside the GeoDatabase, whenever possible, we like to be able to instantiate objects that will have at most one instance that is instantiated, okay? That's kind of similar to the singleton concept, but these things are not co-creatable. Typical types of things that can be uniquely instanced include things like data sets as well as workspaces and versioning, okay? So here, it doesn't matter which API is handing out a reference to one of these singleton objects. You can use different APIs, and we'll demonstrate that, but they will all be referencing the same singleton object, the same reference to the object, okay? And then what that means is even if you have multiple clients all referencing a particular singleton object, if one of them modifies the object, all of them will see the modification, okay? It's not like you all have your own individual versions of that particular row object. You're all pointing to the same row object. One interface pointer modifies it, everyone will see it when they then go and access the properties and whatnot. So, okay, here's some code here. Let's look at this. Up on the top, we're showing we have a version workspace. We go in workspaces themselves, or versions themselves can be uniquely instanced. So here we use one API and say get default version. It returns an iVersion pointer to default 1. And then we use a different method called find version, and we pass in the name of the default version, namely default. Find version is a more general purpose API that can be used for any named version, whereas get default version is only for the default. But then when you go and look at the equality of the two, yes, they are equal. They're the same instance, although we use two different methods to get at that particular version. On the bottom half, we're doing it a little bit different. Here we're opening up a particular feature class named state boundaries. In one instance, it's unqualified, and in the other, it's a fully qualified feature class name. And then when you go from there, when you have you can then go and open up the feature data set on the workspace, and then you can go and ask for the class by name using the same unqualified name through this feature class container. So here we're showing three different paths, three different ways of opening up this particular feature class, but they all reference the exact same instance of that feature class, okay? So there are various ways that you can get at these objects, but we will uniquely instance them whenever possible. Okay, whenever possible, what do we mean by that? If you're trying to instance things such as rows or feature objects, they can only be uniquely instanced if you are inside an edit session. Very important caveat. If you're in an edit session, yes, the row objects will be uniquely instanced. So here, if we look at the code example, we open up the feature class, we ask for a feature object twice, and the interesting thing here is we're not in an edit session, so although we asked for the same feature with the same object ID 1, we get different instances of that feature object. Okay. However, down below, we do start multi-user editing on the workspace itself. So we do start an edit session, a non-versioned edit session. And here, if we do run the same sequence of operations against the feature class to ask for the feature object with object ID 1, they actually are the same instance. Okay, so this is a very simple example showing the difference using the same APIs as to whether you are within or external to an edit session, okay? Important point to keep in mind. Let's talk a little bit about cursors. Cursors, this is actually a very important part of the discussion. You would be surprised how many times back in Redlands I send people this slide deck and go, hey, you need to refresh your knowledge of how cursors work in the GeoDatabase. There are some subtleties here, and let's try and go through those. Inside ArcObjects, we have 3 different class cursors that you can have. You can have SearchCursors, UpdateCursors, and InsertCursors. They're all named differently. They have different capabilities. You get to them through different ways. So we have 3 different cursor types. Now, wonderfully, in the Pro Managed SDK, we do not have this problem. You only have one type of cursor. So a lot of this doesn't apply with the Pro Managed SDK. Important point to make. Back when we were all young and dumb, back in, what was it, 2000, and we released the original version of ArcObjects with ArcGIS 8.0, we exposed everything. We exposed all of our COM objects. It was just a crazy sea of objects and capabilities and all the rest. We thought, hey, how great would that be if we gave you access to everything we have internally? Well, yeah, cool, but not. Because it's very difficult. It's very complex. It's overwhelmingly complex for most people. There are many ways to do different things. So part of the impetus behind developing the Pro Managed SDK was, let's provide an abbreviated yet very functional SDK, way of programming against the system, that only exposes ideally one way to do something, and it exposes only the best way to do something. Let's try and remove as much of this complexity as possible from people that are trying to write managed code against the Pro application, okay? So, some of these things don't apply. But if you are doing ArcObjects development, here they are. There's also a QueryDefCursor. That's when you want to do a defined query such as a join between 2 tables. Okay, that's a 4th type of cursor. Now, what's the difference between these class cursors and the QueryDefCursor? What are the differences here? If you have a class cursor, any row that's returned from a class cursor, meaning a search, update, or insert cursor, will be bound to the class which created the cursor, the feature class of the table that the row belongs to, okay? However, if you use a QueryDefCursor, any row object returned to it is not bound to a class. Well, that seems strange. Why would we do something that arbitrary? Well, remember, a QueryDef can be a join between 2 tables, so it doesn't make sense to bind the row object to 2 different feature classes or tables, okay? Let's see. Let's go through a simple example here. Up on top, go through the beginning. Okay, we start off by we open up the parcel table. Then we do a search cursor, okay, a recycling search cursor when we're not passing in any kind of a query filter. We get the class cursor back. We ask for a row. We get a row object back. We can then ask for the table off of the row object and then do a equality comparison as to whether the table object handed back by the row object is the same object as the table that handed out the cursor that handed out the row, and yes, it is. That's a lot of doublespeak for saying the row object is bound to the table or feature class, okay, that the cursor that hands it out is from, okay? Now here on the bottom, we have our alternative example where we have a QueryDefCursor. We create a QueryDef, we go and evaluate it, then we get the QueryDefCursor back, and we ask for a row object. And here we then ask for the table, and of course we get an automation exception message because there is no table associated with the row when it's handed out by a QueryDefCursor, okay? Search cursors. This is sort of the all-purpose, Swiss Army knife class-based query cursor, query API. The typical APIs that support it are things such as if you call search on an iTable, or get row or get rows, okay? Those all are using search cursors. Now, the interesting thing is when you are in an edit session and you do have a search cursor, that query may be satisfied by the spatial or feature cache that exists or the object pool. We try and optimize the performance whenever possible so as to limit the number of round trips to the underlying database, okay? We try and optimize that if at all possible. Now, other things that are important about a search cursor, although it's a search cursor, you can go and take any row object that's returned from a search cursor and you can modify it. You can update a row that's returned by a search cursor. Oh, that's interesting. Okay, and so when you get a row object back from a search cursor, the store and delete operations on that row object are supported. However, on a search cursor, you do not see methods that you find on other types of cursors, such as insert row, update row, or delete row. These are positional cursor, class cursor methods that are not supported on search cursors. Update cursors. Well, an update cursor is a positional update cursor. Typically, the typical usage pattern is once you get the update cursor, you call next row, then you can go and get the row object and you can call update row on it. Then you go next row. You get the next row object back, and then you can call update row on that row object. Okay? So you're only able to update the rows that are at the current position when you're iterating through your update cursor. That's why it's called a positional update cursor. You can create one of these using itable update or selection set update. When you're running an update cursor, the query is never satisfied by the cache. That's an important thing. This is one of the reasons why you would want to use a search cursor instead. Now, the rows that come back from an update cursor can be modified, but they're not going to be modified using the methods on the row object. Instead, they will be modified using the methods on the cursor object itself because it is a positional update cursor, so you would call either update row or delete row on the update cursor object itself. And you cannot combine those with store and delete, okay? Store events. There are certain types of feature classes that require store event semantics, okay? If the class that you're trying to create an update cursor on does require store events, internally we will create a search cursor, and any call to update row or delete row on that update cursor that's internally a search cursor will become equivalent to row.store or row.delete. Okay, we're trying to protect you and make it as easy as possible. Sounds like a lot of double speak, but this is in case you make a programmatic mistake and you're trying to get an update cursor on a feature class that requires a store event, okay? Now, how do you know if the class needs or supports store events? Very simple, you can see if the feature type is simple or not. What's simple or not mean? Well, think about features inside a geometric network. Those are not simple features. Those are complex features. Those are network features. They do require the store event. Things that require the store event have side effect behavior. When you go and persist that feature, other things will happen. For example, in a geometric network, when you go and persist a point or line object inside a geometric network, those features will, behind the scenes, the topology will be restitched. The network index will be maintained. Okay, so we need to have these additional semantics on the store or update. Okay? Let's see, update row, okay, yeah, errors were called if you're not doing things appropriately, such as trying to update a row and the row is not at the current position through the positional update cursor. Best practices, don't use an update cursor or any cursor for that matter across edit operations, okay? This actually used to be a very dangerous bug in the GeoDatabase where you could keep a cursor open across edit operations. And that could cause problems, particularly in a versioned environment with multi-user editing, okay? Now, that door was closed a long, long time ago. I don't know if that was at 10.0 or before then. How long ago? 10.0? So at 10.0, for a long time, that door has been closed. So I'm pretty sure no one in here is programming against ArcGIS 9.3. Raise your hand if you are. Good. Okay. Just don't pay attention to the slide. It's all taken care of, okay? Now, but the main point here is cursors actually do reference a particular state inside the GeoDatabase. So if you keep them open across different edit operations, the state management logic can get confused and you can lose some of your updates, okay? So you always want to scope a cursor to the particular edit operation. When the edit operation is over, all your cursors should be closed down. Actually, right now, if you don't close them, then you'll get an error if you try and reuse them on the next edit operation, okay? Insert cursors, you use those for big bulk inserts. Say you need to drop hundreds of thousands or millions of features into a particular table or feature class. You want to use insert cursors. Now, the interesting thing with insert cursors is that you can actually control some of the buffering, or when actually you're going to be flushing all the inserts to the underlying database. Okay? Now, you can enable buffering when you set the use buffering argument to true when you call the itable insert to get the insert cursor back. Now, when do you want to call flush in order to control your buffering? How much stuff do you want to have buffered on the client before you start writing to the underlying or backing database? We just generally say 1,000. 1,000 rows is a good number, okay? Now, if you have set a higher interval, like 10,000 or 50,000 or 100,000, you'll be flushing much less frequently. You'll have less traffic, less round-trip traffic to the underlying database. But that starts upping the game regarding how you're going to handle any kind of error management. What happens when you're buffering 100,000 rows at a time and the 85,000th row fails? Something's wrong with it. Then you're going to have to figure out how to do all your proper error management, okay? So that's kind of upping the game. Try and keep it at about 1,000. That's a good rule of thumb, okay? QueryDefCursors. Remember, this is when you're trying to do a join or something like that. You're using a definition query. The row objects, again, are not going to be bound to the class because it could be 2 or more classes that are associated with the QueryDefCursor based upon whatever definition query you passed into it to create it. If you do use it and you call evaluate within an edit session, all the cached rows will be flushed. Also, methods such as store and delete are not supported on rows that are returned by a QueryDefCursor. Recycling cursors. Let's go in a different dimension. So we're not talking about class versus QueryDefCursors. We're talking about recycling. That's sort of an orthogonal axis. What is a recycling cursor? A recycling cursor is a cursor that returns row objects but is not creating a new client-side row object for each row that is retrieved from the database. Essentially, if you set recycling to true, we will reuse that memory location that is storing that the feature object is being used with. Okay? If you do a next on a recycling cursor, we will overwrite the existing feature with the next feature's information. Okay? We will reuse the memory. We will reuse the object instances, including the geometry that that feature may be associated with. Okay? Now, for all the APIs that support recycling cursors, there will be an additional Boolean argument in there where if you set recycling equal true, you will get a recycling cursor. Here are the interfaces that will support recycling. On the table or feature class, you can go get rows, get features, search update, selection sets. You can read it all. That's what you would expect. Here's an example, just showing that the call to next row will return the same row object. In this example, we open up the table. We're going to open up the road node table. From there, we're going to do a search cursor with recycling equals true. That's the second argument. We're not passing in a query filter. That's the null. That's the first argument. We then call the first row iRow object is the result of cursor.nextRow, and second row is the next call to next row. Now, what's interesting is if you look at the equality of first row and second row, they are equal. That's because we're recycling. All the stuff that was returned to first row is then overwritten with the contents of second row, okay? It's not unique instancing, don't get it confused with that, but this is recycling. We're recycling that collection of memory. Let's look at a different example. Here we open up the table, same table. We call table search. We're going to do recycling this time. Do a find field. We then go and we call next row, okay. And then from that first row, we ask for its first geometry. From the second row, we ask for the second geometry. Well, when we start comparing the geometries, they themselves are equal. Remember, we spoke earlier, we mentioned earlier that with recycling cursors, it's not just the memory location for the feature, but it's the memory location for each referenced object, including things such as geometry. We will reuse that geometry for with recycling cursors. Okay? When do you want to use them? If you don't need to persist a reference to the row. Say you're trying to draw or paint the screen really fast, or you just want to search through your data very rapidly and get a bunch of information out very quickly. Recycling cursors are the fastest way to do that. One thing, you don't want to pass around rows that are returned from a recycling cursor, because oftentimes the clients of the particular method that's returning the row object will not consider the fact that these may be rows that were created through a recycling cursor. Okay? You don't want to do that. You also do not want to ever edit a row that's returned by a recycling cursor. Use non-recycling cursors when you want to edit the data. But if you use them correctly, you can save a lot on memory. Here's a simple little example we run. We ran this test quite a while ago, but we had a table with 50,000 rows, 75 fields in each row. If we went through here, nexted through, actually iterated through the entire table, if we were using recycling cursors, we would consume about 60 meg of memory, the memory footprint for this little headless app that we had authored. Whereas if we were using non-recycling cursors, it would consume about 3 times more, because each of the row objects would be kept in memory, okay? Non-recycling, that's a cursor. It creates a new client-side row object for each row that's retrieved. We allocate new memory. We create new object instances, including geometry. Okay, kind of the opposite of recycling. When do you use them? When you need to modify something or you need to persist it, you need to update it. If you need to cache things, if you need to cache a bunch of data on your client, you want to use non-recycling cursors. Okay? And that's what you edit. You edit non-recycling cursors. So let's finish up here. When should you release a reference to a cursor? Okay, as soon as possible. Don't keep those references to cursors open. Also, when you're done fetching, just get rid of them. Get rid of them right away. Act like a Java programmer and let garbage collection kick in. Get rid of the things as soon as possible. Set the reference to null, okay? Let's see, if I need to use a cursor inside an edit session, where should I create the cursor? Well, inside the edit session itself. You need to scope it to the edit session itself. You don't want to start the edit operation, create the search cursor, stop the edit operation, then start a new edit operation, then try and do something with it. That will result in an error. We talked about that earlier. Should I use a search cursor to update rows? Well, that doesn't sound, well, yeah, you should actually. Using search cursors within an edit session is the recommended way to update rows. Not update cursors, but search cursors. This all seems kind of weird. Well, here's the basic summary table. If you're doing things inside ArcMap or ArcGIS Pro, either inside or outside of an edit session, the cursor that you want to use is a search cursor. If you're writing an engine application, a standalone engine application, if you're using edit sessions or not, you still want to use search cursors. The one time where you would not want to use a search cursor is when you're editing simple data through an engine application outside of an edit session. Then go ahead and use an update cursor. That'll give you best performance because you can use the iTableWrite API that's really screamingly fast. Otherwise, just use search cursors, okay? That's the rule. Just use search cursors. That's kind of weird, huh?
It is.
Okay. Let's see. What is the spatial cache? Let's see. Oh, we better finish up here because we're about half done at time. Yeah, we'll finish up. What is the spatial cache? That's a basic way to allow you to cache row or feature objects in a specified extent on the client side to give you enhanced performance. Okay, it can speed up queries quite a bit. We were talking earlier about our cursor mechanisms, and these caches can be used to resolve those queries if they are enabled appropriately, okay? So you don't have to have the round trip to the database. If you're making many spatial queries to a common extent, why not cache all the features in that larger extent, such as the canonical example is people that are editing geometric networks. Say you have a particular project that you're working, a subdivision of some neighborhood. You're working on a neighborhood and you're doing lots of editing. Well, just enable a spatial cache across the entire neighborhood. That way you'll minimize the amount of round trips to the underlying database because a lot of it can be resolved on the client side. Okay? Now there are various ways to work with and manage your spatial cache. You go through the iSpatial Cache Manager to interface, which exposes things such as fill cache, empty cache, return the cache extent, and return properties. You can see it all here in the online help. It's all pretty intuitive and all that. And these are things that are found on either a workspace or a versioned workspace, these interfaces. Now, simple example, here's some, it looks like parcel data of some sort. Say our first query is going to be in this area, second query over there, third query over there, fourth query there. Why not just cache the entire extent? Okay? That's why you want to use a spatial cache. You'll get better performance. And here's how you do it. It's really not particularly hard to use a spatial cache. What about the Schema Cache? Well, that's essentially a snapshot of the underlying GeoDatabase schema, essentially the metadata associated with all the dataset types inside your GeoDatabase, okay? Now, internally, we use the Schema Cache for doing certain types of operations that can open up a large number of feature classes or tables. We don't want to have to keep querying the system tables in order to get the metadata out. We're just going to say, give us all the metadata for everything, and we can optimize it on the client side. So we're trying to cut down on round trips to the database whenever possible. So when we open a map document in ArcMap or ArcGIS Pro, when you open up your documents, we'll enable the GeoDatabase Schema Cache, and then we'll tear it down right after we're done with the operation. When you're doing operations such as a reconcile, prior to doing a reconcile, we will enable the Schema Cache, do all the processing. When the reconcile is done, we'll tear down the Schema Cache, okay? Now, Schema Caches are useful when you have a relatively static data model, when you're not changing the data sets, you're not adding new data sets, not adding fields, not adding domains, subtypes, default values, whatever. Things are relatively static. That's when you want to use the Schema Cache because that's a snapshot of what your schema looks like. Now, it is very useful when you're opening up a whole bunch of data sets because you're reducing the amount of round trips to the underlying GeoDatabase schema tables in order to get the information to properly instantiate all of those different data sets. Okay? And here are the analogous APIs for working with the Schema Cache. Okay? And those are found on the workspace factory, not on the workspace itself. When do you want to use it? When you're working with large static data models, or if you're opening and dealing with a large number of classes. When you open up everything, you may want to grab the Schema Cache or enable it before you go and do these operations. Okay? Let's see, we're just saying the same thing over and over. It is possible if you do have a Schema Cache to determine whether or not it's stale, and you can go and refresh it. And if you do have a Schema Cache open, it's your responsibility for disabling it. It's, you're kind of assuming a good amount of responsibility here when you're using a Schema Cache, but they can improve performance very nicely when you're opening up a lot of stuff. Just follow the rules. Okay, here's some simple code just going through. Okay, we're opening up the workspace from the workspace factory. We enable the cache. Then here we're going and opening up a feature class. Maybe we open up all the feature classes. Then at the very end of the operation, we're going to be a good citizen. We're going to disable the Schema Cache. Okay, gotchas. Things can get stale. Okay, if any schema change occurs through another application or whatnot behind the scenes and you don't refresh your Schema Cache, you're kind of out of luck. Schema Locks.
Yeah, so let's talk about what happens when we do want to make a schema change. So schema locking is a concept that we have. When we open up a data set, we take a read lock. And to make a change to that data set, what we want to do is promote that read lock to an exclusive lock. So it's our responsibility as developers to both promote, apply the changes, and then demote that exclusive lock. If we forget to demote the exclusive lock, then no one else can open that class until it's done. So there's many different things some obvious and some not so obvious that require schema locking. I think an obvious one would be the example we've given of adding a field, or anything that happens via the iClass schema edit interface. But there's some that are less obvious, such as adding a coded value to a domain, or placing a class in load-only mode for loading data. So these are some of those things that you should look at and think about when you want to take an exclusive lock, and just remember that when you error or finish the operation, it's your responsibility as the developer to demote it. Now, thinking about what an exclusive lock means, no one else has access to that table, we want to make sure that the duration in which we hold that exclusive lock is the absolute minimum. So if you have an experience where you pop open a dialog and let the user allow to type in maybe the field names that they want to add, please gather that information before you promote your lock to exclusive, right? And keep the duration of the exclusive piece down to the add field call, rather than the entire GUI operation of allowing the user to type in information. Okay, the next section I'd like to go through is an introduction to the CoreData. This is the managed SDK, C#.NET for ArcGIS Pro. And it's how we access data in ArcGIS Pro. So one of the things that we wanted to look at, as Eric said, was what do we do right in ArcObjects and what do we do incorrectly in ArcObjects, or how could we do it better? And at the same time, we wanted to build this external-only API that was used for extending ArcGIS Pro in an add-in capability, right? It's not for our internal consumption. It's not the same things that we build it with and then just expose it to you, but these are specially made extension APIs, right? In ArcGIS Pro, ArcObjects is not exposed. This is the only way that you have, along with Python, to interact with your data. One of the decisions we made was to make the API a data manipulation language only, right? It's only about accessing the data and not making schema modifications. This immediately cut the scope of the API down astronomically, actually, and allowed us to create a concise and discoverable API for you. You may ask, so how do I do add field? How do I create a feature class? Well, there are geoprocessing tools to be accessed through the API, and that can be executed to do these patterns. Yes, you could also script these patterns via Python, right? If you had something that you wanted to create a feature class and add many fields, then that can be scripted in Python as well, instead of called directly from a C# API. So the pattern that we wanted to take with the CoreData was that we started with a minimally complete story. We matched what ArcGIS Pro could do at that current release. It's been released for 6 releases now. It's quite a bit. And each release it has grown with the functionality that Pro has. We started out with the Web GeoDatabase simple data model support for file and enterprise geodatabases. This is tables, feature classes, relationship classes, domain subtypes. And we've grown from there. 1.2, we added versioning and feature service support. 1.3, we added database access. This is query layers and QueryDefs. Eric talked about those for joining classes. At 1.4, we added joins, the SQL syntax helper class to allow you to write better SQL. And feature services became geodatabases at 1.4. At 2.0, it was a breaking change. We introduced a data store update to support file-based data stores, as well as supporting rasters, editing blob fields, and we removed data store.getPath. And that was a mistake. So the next release, we added it back. And what this basically does is allow you to run to get the path for an enterprise geodatabase and execute geoprocessing tools by sending that path to the tool, regardless of how you open the data store. If you opened it from a file, we always had the file, but if you opened it from a connection property set, there was no file to pass a string to geoprocessing from. So we added the capability to get that, and we temporarily create a connection file for you. As well as some convenience methods, table.getCount and the unique instance ID on the table, so you can compare those objects and see if they are the same. As well as versioning was enhanced. We added the ability to create and alter versions, delete the versions, reconcile, and deal with conflicts. And feature services became capable of supporting these long transactions as well as reconcile. So let's take a little bit of a look at the architecture. At the bottom of the architecture, underneath Pro is still ArcObjects. And then there's a C++ wrapper layer that wraps those ArcObjects and exposes them in a managed C# layer. And that's the Pro SDK. And those managed pieces are consumed by the client and written as add-ins to extend the functionality in a loose coupling, not like class extensions, but in a looser coupling at the client level. So this architecture diagram is actually the same as what ArcGIS Pro is built with. Right? Internally, we did the same process, but we wrote internal APIs, and we wrote nicer and prettier external APIs for our developers to use. So let's take a look at what's in core.data, right? At the base of it is a data store. And this data store has specific types, a GeoDatabase or a database data store. You can think of these as the workspaces of the core.data model. On the data store class, you can get things like get path or get the SQL syntax. And then from the data store specifically, like a GeoDatabase, you can call open dataset, passing in a generic type of dataset that you want and the name. So this is a second pattern that we wanted to enhance. We didn't want to have 15 interfaces for opening tables, feature classes, utility networks, topologies, etc. We have one generic pattern where you pass in a generic and ask for the thing by its name. You can also get definitions, get the domains, and get the GeoDatabase type. So how do we connect to these data stores? Well, we do that via data store constructors. So rather than let you fiddle around with a set of strings that may or may not be correct, the constructor pattern tells you what you need to provide and helps you in making those connections. We have a file system connection path for connecting to shape files or text files, a database connection properties for connecting to geodatabases or databases, a file geodatabase connection path that takes a URI, as well as service properties that take a URI or a URL. So moving past the data store, we have this concept of data sets, and data sets have definitions. And we'll talk about the definitions a little bit more later, but the dataset abstract class has things like get the data store from which the dataset was from, get the definition for the data store, or for the dataset, its name and its registration type. So here's an example of a dataset, a table. It's the heart of the data access API, right? It's a single class with a set of methods on it. This is unlike ArcObjects, in which I think the table class in ArcObjects had 45 interfaces with 5 or 6 methods or properties each, and it was a little bit harder to understand where and what you needed to, but it did make for an excellent OMD diagram, which is on my wall. So hopefully this is a little bit more discoverable pattern. The table class is where you call search. Right? This is where you call search, where you can get count, where you can create rows, where you can validate. And from that, or adjacent to that, is the table definition. And this is the information about that table. What fields does it have? Does it have editor tracking? Is the time stored in UTC? The interesting part about this is you can get the definition without ever having opened the table. Right? So this is the lightweight mechanism to interrogate your data sets. Right? Get information about them without ever taking the cost of opening the entire class. From the data store, remember, you could ask for the definitions. You can ask for the definitions of a type, and therefore find all of the tables in your data store without opening every table. So extending a table is a feature class, and this is basically a table with a shape, attributes, and it has a matching feature class definition that gives you information about what the shape length and what the shape field names are. So these definitions are where you go to get the information about those classes, about those data sets. And as I said, you can enumerate through them and, in a lightweight manner, discover what your geodatabase or data store contains. So from a table, you can get rows. And you do that via a row cursor with a move next current pattern. It's a enumerator C# style pattern. The CoreData API took a very row-centric approach. One example of this is that when you're working with attachments in ArcObjects, you would have passed a set of IDs to the table and said, add attachments to the table for these IDs. In this API, when you have the row, you simply call add attachment on the row, and we add the attachment to that row. So we changed the thinking about how some of these things happen, but the same functionality is still available. A row may be a feature if it comes from a feature class. Rows, if they're open from search, have a tie back to their table, as tables have a tie back to their data store. So how do we get rows? Well, we use query filters. And those query filters help restrict the information from the table. They take things such as a spatial reference, a postfix clause, a prefix clause, subfields to reduce the number of fields that return values, as well as a where clause to constrain that via an attribute query. For a feature class, those query filters can be extended with a spatial aspect of the spatial relationship, a search order, or a filter geometry. And when you use these query filters on a selection set or a table, calling search, they return a row cursor that you can walk through. Oh, I should just mention that those row cursors do support recycling. In the same pattern, we have a Boolean property that you can ask for as a recycling cursor or as not a recycling cursor. At 1.3, we introduced QueryDefs. Eric mentioned this is a very powerful way to write your own join within a data store. If you wanted to persist that row cursor in a table form to use in geoprocessing or as a layer, display it as a virtual table, you can do that through the open query table description and calling open query table on the GeoDatabase. So it's a good way to write very efficient joins. Yes, it's very powerful, as Eric said. 1.3, we introduced the database access concept. Here we can access databases that are not enabled with GeoDatabase metadata and access rows and information via a query description. And you ask the database for a query description via the name of a table you want to open or via a query that you have generated yourself. And when we have the query description, we can ask open table, and we get back a table. This can be an attribute table or a spatial table. If it's a spatial table, the query that you defined must still meet the requirements of ArcGIS. Mainly, it has a unique ID field and that it has a single geometry column. And the geometries returned from that column must be of a single type. So they can have mixed entity types in the field, but you must restrict them as the developer to a single type, point, line, polygon. Joins were introduced at 1.4. QueryDefs were great inside of a workspace, extremely powerful. Inside of a data store, single data store, extremely powerful. But what happens if A, I don't like writing SQL, or B, I want to do a cross data store join? That's where the join class comes in and really starts to shine. So joins can be built off of relationship classes that are stored in the GeoDatabase as actual objects or from virtual relationship classes, which you define which two classes relate, either from the same workspace or same data store or cross data store, and then ask to join. And what we produce is a join table, similar to the process of doing it in the GUI through the layer. At 2.1, versioning was enhanced again, and from the GeoDatabase, you can ask if that particular GeoDatabase does support versioning, as there are feature services which can be published with version management services now, or enterprise geodatabases which support versioning, or file geodatabases which do not support versioning. If versioning is supported, you can ask for the version manager, and from there you can connect to a given moment. You can create versions or delete versions from the version. You can get a historic version, or connect to or ask for any of the public versions that you can see. From the version, as I mentioned, you can alter it, you can delete it, and you can reconcile. So now reconcile is not a geoprocessing tool that you need to execute, but can be done from the add-in itself, and the conflicts can be read. So the last thing I wanted to point out is that the conceptual help for the Managed Pro SDK is on these two links. We have a large collection of community samples that lead you through the canonical form of how to access a cursor or how to connect to a data store of a specific type. It also leads you through some of the interesting pieces of writing a multi-threaded application, such as the CoreData API must be called within a queued task. And that's an entire another presentation of itself. So we will, the two things I wanted to call out there are the GeoDatabase subsections, specifically the snippets and the concepts, and you'll notice that I didn't talk about editing very much, and that's because in the add-in model, we want you to use the editor to do that editing. This is a very important pattern in Pro. If you want it to refresh correctly, you need to use the editor to do those edits. So the SDK examples and samples help you lead you through that process. Okay, the last section I'd like to do is top developer mistakes. Okay, these are mistakes that we've seen either from tech support or internal or via code review, and they come up over and over again, so we want to just highlight some of them. Eric's mentioned a couple, but we'll go over them here. So the first one is misuse of recycling cursors. Basically, it was the idea that he mentioned that when we have recycling cursors turned on, the cursor allocates memory for a single row, regardless of how many rows are returned from the cursor. And it can be very confusing the first time you run into that, so we just want to remind you of that again. So here's the example. We open the feature cursor, we call search, we get the first feature back, get the second feature back, and they and their geometries are equal. It can be very confusing. Okay, next one. This is my personal pet peeve, and I yell at everyone who does a code review with me that has this problem. Calling find field in a tight loop. It is a small cost for us to look up the index, but if you ask us to do it on every single row for every single field you want to access, it is a large cost. So in some of the examples Eric had, he asked for the field index and cached it in an integer value in his application and then passed the integer value in, as opposed to this person's code who, inside of the while loop, asks for the feature class.find field by name each and every time it goes through a row. So this is a pattern you definitely want to look out for, right? If you simply do the feature class.find field name outside the while loop and cache that value, pass it the cache, we'll never look it up, we'll just use the value. This was such a big problem and that we took a different approach in Pro. In Pro, if you wrote this code, I would nod and sit here quietly. We internally cache the ID for you in the managed layer. So still don't do it. I want to see all index ones. Okay, so last thing, or no, not the next thing, the cursor across edit operations. Like Eric said, when we had people who put up their hands for 931 and we didn't have anyone, we would say, hey, go back, take a look at your code, make sure that you are scoping those cursors correctly to the edit session. I'm hoping this one's actually being phased out at this point, right? We have very few clients who are still migrating or working on 931 code. But it was blocked at 10.0. Don't do it. You won't be able to. Here is probably the most requested thing ever on the ideas side. I want to add fields while I'm editing. Can you please just do that? That seems simple, right? Well, yeah, it does seem simple, but there are complications, right? Specifically in the transaction model. If we're calling create table or table.add field inside of an edit session, we probably just committed your edits, right? It's a commit in the database. And now, what happens when you do something or realize that you moved 50,000 features before that add field? There's nothing I can do. So this is just an explanation about one of those things that users always ask for and why it's not as easy to request that thing. Also, if this happens to you, I would stop the edit session if you want to do that DDL. Next thing is an interesting case that we had where in a store event, people were calling store. And as you can logically see, if you call store inside of a store event, what happens? The event fires and you call store again and you sit there sitting like, why is ArcMap taking forever? It's never coming back. It literally isn't. It's in an infinite loop. So if you're in a store event, do not call store. Slightly more subtle is if you're on an onCreateFeature event, don't modify the shape of the feature being created. Now this has real impacts if you're in a geometric network scenario. When you're working with features from a geometric network, we have made calculations based on the geometry that was passed into this. If you change it afterwards, let's say unexpected behavior is a good way to put it, will occur. Depending on how you change the shape, things might have worked out, but just don't do this. And on the onCreate, of course, don't call store as well. So this is one I am terribly guilty of. I am very lazy. I got my indexing right when I looked for find fields. However, inside of this, I didn't use the method that ArcObjects gave me to search multiple or to return multiple rows at a time. I simply called getFeature over and over and over again until I had all of my features. Why is that bad? Every one of those getFeatures calls is a new cursor. So instead, I should create an array of those OIDs and use the getFeatures call, which does that in a single cursor. I'm terribly guilty of this. I hope none of you are. It's convenient. It's right there. It says getFeature. OK, next. OK. Oh, this was an interesting one that came in from an internal client. The user had opened a name object, right? This name object is like a shortcut or a moniker to the data set. And then they'd open the data set and they'd release the data set. And they assumed that by having the name object held, that we still had a reference to the table. It's not true. If you want to keep a reference to the table, you need to have the data set itself open. So just because you have the shortcut and you haven't released the shortcut doesn't mean that we'll cache the open data set. So basically what they ended up seeing was queries over and over to the database to go open up that thing which they thought we had cached locally. I can remember the email for this one. This happens all the time when people say, hey, Colin, the GeoDatabase is broken. And I say, really? The GeoDatabase is broken? How is the GeoDatabase broken today? Well, every time I try to create a class, it creates 50 name fields in my class. I was like, huh, that's interesting. Can I see your code? And I get something that looks approximately like this, where they define a field, but without calling new field, as I do at the top, the third line down, in between setting the variables, they continue to change the in-memory representation of all of the fields which they've added to the field set. So by the end, all of the fields in the field set look like the last one that they set. So just be careful when you're reusing variables, right? If they had done something like, I don't know, iField edit 2, right, and incremented their variables, they wouldn't have hit this, or if they had correctly called new field class in between each add field set. So this one also came from the same team. I'm not going to pick on them, but the idea of some schema changes happen immediately, and some schema changes are delayed. Specifically with the canonical example is this class add field. As soon as you call class add field, field's added to the class, right? Assuming you have a schema lock and you were able to do it and there's no error returned from the database. However, there is a second pattern in ArcGIS's wisdom where we allow you to add that field to an in-memory field collection, right? This does not add it. Even if you get that field collection to the table, this does not add it immediately to the table. There is a method to add those fields, but it is an in-memory change which happens. A small side note on this, if you happen to be working with in-memory workspaces, then changing the in-memory representation is effectively like adding a field. Small caveat. Inserts and relationship class notification are not free, right? Relationship classes in the wizard allow you to set them up, and there's 3 options. And everyone thinks that more is better, but it's not necessarily more is better. Relationship classes support forward messaging, backwards messaging, and both. The only thing that ArcGIS takes advantage of out of the box is forward messaging, and that's for composite relationships. You can think of annotation how when you move the feature, the related composite relationship says, hey, other feature, Anno, specifically, move along with it. So if you were going to create a relationship class, just think about what messaging you are going to actually extend, and if you're not, make sure you say none for any of the messaging. Also, this is a good place to use the Schema Cache. If you're going to edit a feature class that has relationships, it is better to open all of the relationship classes that are going to get these messages before you make the edit. So this is just a summary of those top developer mistakes. Don't do the fine field one, please. That's all I ask. No. There's lots of them there. Lots of good things to go back and look at your code when you get back in the office. Here are the things that we've talked about. I think that's about the end.
Yeah, long time.
Yeah.
Okay,
Exactly.
Thank you everyone for coming. If you have questions, I have to run to another meeting. Colin will be here for a while, but you, sorry. Thank you everyone for coming. I have to run to another meeting, but Colin will be here for a little while. And then you can always just drop by the island on the floor there and ask all the questions you may have. We're here for all day long to answer those questions.
Until 4, yeah?
Yeah, pretty much.
Yeah.
Okay, so thank you for coming.